learning what is data science. And I just want to show you some of the real world use cases related to data science, and also like what is the screen time. Suppose if we are having a movie, or if you are going with some sort of videos, we can determine what is the screen time of a certain character. So I would like to show the real world implementations of the Tom and Jerry screen time, as well as accidents. I'll take into account an accident use case and show you a sort of classification problem. And during the job, whenever we are working on data science, there is certain amount of process normally we have to follow as part of the data science. So we are going through a bit detail into the data science process, and then we try to understand what are the roles that are present in the data science. When we are talking about the roles in data science, there are multiple roles. If you look into Google, or if you are looking into Microsoft, or different, when we talk about companies, normally they have different types of roles in their company. So we will be looking what type of roles are they offering as part of the data science, and also I'll show you the real-time implementation of one of the scenario, and then we will be going through the course content. This is what is a demo per demo, whatever we are covering as part of the demo. So since we have been seeing like from the engineering part, whenever we are into our graduation, we see that data science is also one of the subject for computer engineers. So they would have covered to some extent, not to the extensive part, but at least on the basics part, they would have covered something. But whatever the content that is covered is very, very minor. So if we look into the other graduation, I mean, if we look into electrical, I don't think so that normally these subjects are not taken into consideration. So whatever training normally we provide is from the basics. So when we take into the data science, we go to each and every basic of the programming part, and also the basics into the algorithms, and also very basics into the graphical part, and from there normally we go through each and every part of the data science. So starting with the understanding of the data science, we normally hear here and there, everywhere in the world, normally we hear nowadays the buzzword is data science. So when we try to understand what is data science, there are different definitions that are provided for data science. So if you look at the definition here, normally what do we say? Normally we say that data science is the use of scientific methods, processes and systems normally to extract the knowledge. So just instead of reading this, I'll tell you what is a data science from a simple perspective. Data science is nothing but some sort of what we say in the sense scientific methods. When I talk about the scientific methods, we used to learn statistics in our intermediate, in our school, in schooling, and also as part of our degrees. So scientific methods are nothing but our previous computing abilities and the processes that uses these abilities, and using these abilities we are trying to extract the knowledge and try to analyze something based on the data, and we are going to predict the future. So when I'm talking about data science, is nothing but data and science. If you're splitting the data in science into two words, data and science, you are applying science on top of data. So what is science? Science is nothing but a set of methods or processes, and what are you doing on top of data is nothing but making use of these methods and processes. You are trying to extract the insights, and you are trying to extract some or analyze something based on the data, and you are going to predict the future. That is what is a data science. So when we are talking about data science, people talk about machine learning, people talk about deep learning and artificial intelligence. And most of the people, when I try to talk with them, normally people say, is machine learning different, data science different, or if it is a deep learning different, or data science different? No. The combination of machine learning, deep learning, and artificial intelligence is everything. The combination of all these things is nothing but a data science. So just to give you a high level understanding of this machine learning and deep learning and artificial intelligence, what is happening in the sense, when you are talking about the machine learning capability, when you have only certain amount of data, if you are talking about only certain amount of data, which is not too much in zettabytes, or if it is not in large amount of data, if you're having certain amount of data, which is not so huge, or if you think that you don't really need to memorize the data, in certain case normally we go with the machine learning, we go with the machine learning use case algorithms. So when we are talking about the deep learning, here comes the human capability of memory. So like how we have our neurons in our mind, and how we have this memorizing ability. Similarly, we have the concept of neural network concepts in deep learning, where you are going to memorize the data, where you are going to remember the ups and downs of the data. You are going to save the analysis whatever you have done, and go making use of the memorization. You are going to predict the future. Here, for example, suppose I have the data related to January, and in another 2 days I'm going to get the data related to February, related to some sales. As part of the machine learning, if I'm running January data once to understand the historical insights, or to understand the analysis, if I run January data once, and tomorrow if I get February data, what I should do in the sense, as part of machine learning, I should again run January as well as February data to get the insights. But as part of the deep learning, it is not the case. Once you have run the January data, it stores that particular insights in the memory, so that next time when we get the data, we can just run the February data, and we combine the analysis, and based on that predict the outcomes. So that's the difference between the machine learning and the deep learning part. So when to use machine learning and when to use the deep learning or the artificial intelligence, we will be studying in depth, because we have to understand what are all the different places where we have to implement what algorithm, when to implement what algorithm, and how to implement an algorithm. All these will be covered as part of our course. So coming back to machine learning, deep learning. So what is that? If you look into this, the entire world is nothing but data. So everywhere you go, either you're going to a store, you're going to a medical shop, or if you're going to any sort of place, everywhere data is maintained. Since we have lots of data everywhere, we now have the data, lots of zettabytes or lots of data in hand, so that we are going to make use of the data for some sort of analysis, and we are going to make something out of the data, and we are going to predict the future. So as part of the some of the researches that has been done, the jobs that are being, if you look at the jobs that are offering jobs, or job that are offering, most of the time, if you see, the number one place is taken by the data science, and there are multiple companies. There are lots of companies who are employing for the data science roles. So there are a lot of companies, not only in US, but also in India. If you see, there are many startup companies who have already started hiring the data scientists, since they have got lot of R&D projects in their hand, and there are multiple startup companies in Bangalore or in Hyderabad who are hiring data scientists. So what are we going to do in the sense? I'm going to show you a video related to Tom and Jerry. Just have a look at couple of minutes, just have a look at the video, and we will try to understand what sort of analysis can a deep learning or a machine learning algorithm can do based on this video. Okay, so I'm just showing the video. So if you look here, normally the video which you have seen is a Tom and Jerry video. So what we are going to do in the sense in this particular video, we have seen that we have two characters over here, Tom and Jerry. And if you look at the video, as a human, can I determine the screen time of each and every character? It is quite difficult, right? As a human, it is quite difficult for me to determine the screen time of Tom and Jerry. So what we are going to do in this, in the sense, as I'm showing you during I will be showing you during the implementation part, what we are going to do in the sense, when you have a particular set of videos, we can determine my machine learning or the deep learning algorithms or the models that we are going to create, or we can use the existing algorithms also. So the models will be able to learn from the video that I am providing. It means it is going to learn what is Tom, the character, and how do they behave, and what is the each and every object. Normally all this can be learned by the machine learning algorithm. And end of the day, when I want my machine learning algorithm, or the deep learning algorithm to determine the screen time, it will show me what is the screen time of these two characters, making use of something called the deep learning algorithms, and we are going to display the screen time. So if you look into one another use case, I want to tell you a real client, I mean, which I have as part of the requirement. Nowadays, we do have security cameras which are being implemented at each and every home. So what is the client requirement? In the sense, one of my client requirements says that whenever we have a person who is coming with a chalk, or if he is coming with a gun, since the data, the video is, everything is streaming, right? Online streaming, and you can look it over your mobile phone. So what should happen in the sense, whenever we have the online video, if any person is coming with a gun, or if he is coming with some sort of with any sort of sword or any sort of knife, my camera should be able to detect that particular object, and it should be able to immediately ring a sort of siren. So this is one of the requirement, and this is some sort of product that my client want to develop as part of this, as part of the artificial intelligence product. So see how the world is moving. That means here, if you look at this particular video, there were a lot of objects, not only the characters, like a lot of objects. So my machine learning or the deep learning algorithm should be able to learn each and every object or each and every character. What are the from the characters, they should be able to determine what is the video screen time of this particular two characters. So now coming back to another use case which we will be seeing, I have a set of accident images which have been taken from US as well as from India. So the accidents can happen during nights, and the accidents can be happening during snow, and the accidents can happen during some other rain, during rain time. So I have taken three different classes where I took photos of the accidents happened during rain, during snow, and during nights. So when I give this particular images to my model learns based on the features, and based on the features, the model determines tomorrow if I want to provide another photo to determine what type of accident it is, my model will be able to determine this particular accident belongs to either it happened in the rain or in the snow or during night. So that is how the image processing front, not only on the image processing front, it is happening on the text also. Like if you look into the BPOs, now everything, there is not many people who are being recruited at the BPO. Now you have your chatbots available, you have your text analytics in place, where everything is happening, making use of the text processing. And what is doing, the machine is doing, the machine is answering you, the machine is filling your answers, it is providing you all sort of query answers. So everything is happening making use of this machines itself. So if you take into the in-depth understanding of what is really happening there, it is nothing but the data science and the artificial intelligence making use of NLP, natural language processing, or making use of text analytics. You get all sort of answers from the chatbots or from the different bots. So these are some of the real world scenarios. I'll be showing the implementation in quite some time, but I just want to provide you how in the real world scenarios that we are going to make use of this data science. As I was telling you, data science has a certain process. So when we look into the process, like if whenever we used to work on a project, from the last, I have been into an IT from the last 15 years. I worked as part of the product development at Oracle. I worked at Hitachi. I worked at Tech Mahindra. So as part of the process, everywhere I worked, I have been working on a particular cycle wherein you have the requirements gathering, you do the analysis, you write technical design documents, and then once you are done the technical design, you do the development, testing, and all those things. So similar process like how we used to do before, data science have a different set of process where you are going to do in your real world scenario. Suppose the first thing, whenever you are provided by a client, whenever you are provided with a requirement by the client, it is not always be clear in data science. So the client asks me, I want to predict something. So when I want to predict something, what is that I have to predict? So you have to keep on asking multiple questions, because it's not like other requirements in the different projects, but in data science, you have to keep on digging more and more to get more and more data from the customer. So the first thing, whenever we are going to the data science process, is nothing but an asking an interesting question. So based on that, which is a really, really important step, because based on those itself, you're going to do the analysis, you're going to do your modeling, you're going to communicate the results back to the client. So the first and important step as part of the data science process is nothing but an asking an interesting question. So now you have your data. Now you have got lot of data, like I have the sales data. Okay, I have got all the data, and I got the data from the database. The data is in the form of files, so I got all the different types of data. Now what do I do that with the data? So the data can have some issues, right? The whatever data I get is not really perfect. So what I'm going to do, I'm going to pre-process the data. That means I'm going to remove some duplicate records. I do clean off some sort of values which are null values, because they doesn't give me any sort of insight. So I have to clean the data, and once I have the clean data, I'm going to use them for my analysis. So what is that? According to what the data scientists say, in the sense, data speaks something. So when I'm saying something, data, it really doesn't speak, but as part of what we say, data speaks something. So if you look directly into the data, that data tries to tell you some sort of analysis, and it will show you certain trends. Okay, normally the sales are going up in this particular month, or the sales are going up from the last 5 years, the sales are going up, going down in this particular month, and you get certain sort of insights during from the historical data. That's the reason we normally say that data speaks. So when we have the data, once we have the data clean, normally what we do, in the sense, we try to explore the data. So normally we try to check what are the patterns. Suppose I have a kids store. I try to understand, see, every December, because of the Christmas time, the sales go up, the toy sales go up, or there is certain amount of sales that goes up to each and every sector. So as a human, I know, but how will machine know? My machine know based on the data, the previous historical data, and from the previous historical data, it will be able to analyze something, and it provides me some sort of patterns, and it tries to provide us some sort of exploratory analysis. So once you have the exploratory analysis, this is still here is nothing but my data analysis. So once I'm done with my analysis, am I done? No, I want to know about the future. So can I really, as a human, can I tell the future? Not really. So what do I do, in the sense, I have certain models that are predefined models that are existing as part of Python and R, and I'm going to use those models to determine what is going to happen in the future. So I normally, what do? I have the historical data. The historical data, I'll be providing them to my models. I ask them to learn. So I'll tell them, this is the question, this is the answer. So if you look at the video before, the Tom and Jerry video before, I tell this particular frame, this is top. This particular frame, this is Jerry. That's how my machine will be learning based on the labeling that I provide for each and every frame, and how whenever I try to provide another video, it should be able to determine the character. It will be learning from the character, it will be learning from the features, and it will be providing you the exact results. So in the similar manner, so whenever you are providing your sales data, historical sales data, you are going to provide the historical sales data to the models, and once it learns, whenever you, tomorrow if you want to know what is the future, it will be telling you. If you are predicting sales for the month of October, it will be telling you, it will be able to tell you with certain accuracy, okay, your sales will be going up with this particular amount. Your sales will be going down by this particular percentage. So that's how that's how your model will be telling you with a certain accuracy. So whenever you have the accuracy, and once you provided the prediction results, everything in the form of numbers, you cannot directly take the numbers and show you to your VP or your sales head with the, see, this is the model I have. No one understands the model at that particular level. So you have to show that data in the form of graphs or visualization. So that's the reason we have certain amount of certain packages or the libraries that are available as part of our Python, or we have different packages also that are available. So making use of them, we will be showing our results. So now coming back to the implementation part. Okay, so I'll just show you one of the implementation part. So this is the one which we have seen before. Whatever you have seen before is the Tom and Jerry. This is the MP4 video that you have seen. So what I'm going to do in the sense, I'm just showing you at a higher level how does a model behave. Okay. So how is my model behaving in the sense, initially I have provided a file, Tom and Jerry video as an input. And what is that I'm going to do in the sense, as part of the different packages that are available, this video is divided into frames. So what is happening as part of the frames, if you look here, the code itself is dividing the video as part into different frames. That means for each and every second, you will be seeing these are the number of frames that got created from the video. So see, these are the number of frames that got created from the video. So what am I going to do in the sense, for each and every frame, I'm going to tell I'm going to mention that this particular frame is having Tom. This particular frame is having Tom. So, and another frame, Jerry is there. Here Jerry is there. So each and every frame, I make my machine learn, so that the machine learns, makes use of each and every. If you look into one of the frame, so here you see Tom is available. This particular character is there. How does my machine learn? So my machine learn making use of the facial features, these particular curves or these particular curves. And whenever you see here, my machine learns based on the features, and based on that it tries to understand the characters, and that it provides the results. So it doesn't mean that if I really tell, okay, this is Tom, it is not going. Tomorrow if I give some sort of dog image and say it is Tom, it is not going to learn that way. Based on the features, whatever it is trying to learn based on these features, and for each and every photo in different motions or in different angles, it tries to learn that particular feature, and it will try to analyze the results. So once it divides into frames, so what is it doing once we have the frames available? So once it have the frames available, this is what is the first image. This is my first frame. Whatever you are seeing, my video started with this, and this is my first frame. So what I have done in the sense, I have assigned a class telling that this frame has Tom, this frame has Jerry. So mentioning these, this frame has Jerry and this frame has Tom. For each and every frame, I'm providing question and answer format. I'm preparing it in this question and answer format, and I'm making my machine learn. So what is that I'm going to do in the sense, here making use of a base model, I'm training my model. This is one of the model which I'm used as part of TensorFlow, which is nothing but a deep learning, some of the packages. So I'm creating a model, I'm telling my model to learn based on this particular input. So what am I doing here? I'm going to train initially. So once I'm going to train, I'm going to see, if you see here, I'm going to train with, this is my particular model. And once I have the model, I'm going to train making use of the input. This is a train data. This is my input data. This is the questions. And this is my particular answer for that particular data. And I'm telling that I'm giving you 10 iterations. Whatever you do, you go forward, you go backward, whatever you do, in this 10 iterations, you try to understand the features and you try to understand the character from in this particular 10 iterations. So what is doing here, epochs is nothing but iterations. So what is happening in this particular case in the sense, for each and every iteration, if you understand, there are 208 images. So from each 208 images, for each iteration, it tries to learn first time when it is trying to learn, you see the accuracy is only 42%. That means it is not able to understand the characters properly in the first iteration. It goes back with the error, say it goes back with the error, and now in the second iteration, it learns its mistakes. And if you see here, it's 78% accurately it is learning. Next, going back with 87, next going back with 92%. So slowly for each and every iteration, it is developing. And by when it is coming back to the last iteration, you see the 99% with 99% accuracy, it is able to learn the day from the data being provided. So if you understand in the real case scenario, suppose if I have a question paper and I know only half of the answers, what will I do? I'll half of the answer, I get only 50% answers. Second time I'm given a textbook, again, I'm asked to read the same questions. Now you give me the same question paper. What do? I read, I perform better. The third time you give me the same, I perform more better. That's how we keep on improving in each and every iteration. The model improves at each and every iteration and performs the results. So once I have done, okay, I'm making sure that my model has learned the Tom and Jerry use case. What I'm going to do in the sense, I'm going to provide another video, which is nothing but another video, which is not the same video. This is another video, which is Tom and Jerry 3. I'm going to provide this particular video and ask my model to determine what is the screen time. Now you tell me, since you have learned who is Tom, who is Jerry, you tell me how much is the screen time of Tom and what is the screen time of Jerry. So when I have this particular thing, if you come back again, I'm going to divide them into frames again. Now, I'm not going to tell which frame has Tom and which frame has Jerry. It is going to read that particular frames, and what is it going to do? It is going to predict here, and in this particular predictions, it will be telling that the screen time of Jerry in the test video, what I have provided is very less, which is 3 seconds, but the most of the time, the screen time of Tom is 140 seconds. Okay, this is how normally it is. Not only in this particular scenario, suppose if you are going with object detections, so as I told you in the real world scenarios, the videos, if I'm capturing a video, like if there is a thief who is coming with a knife or a pistol, I should be able to determine that a particular object is being holded by that particular person, so he is not a correct person. So immediately by my machine should be able to, my model should be able to determine him as a thief, and it should be able to notify us so that we can send the notification back to some alarm. So this is how the technology has advanced. So this is how the technology has advanced, not only on the image processing front. If you look into Google, whenever you're going to Google, normally what does a Google provide? So if you look here, if I'm going to Google, I say image. So when I say image, so see how many sort of options is it providing us. So what are the options? How is it able to provide the options? Because it is learning from the historical data. Based on the historical people, many people around the world are searching with image. So it should be, it is learning like what would be question, next question will be, and it is providing us all these particular matches. That's the reason you are able to see it here. not only from the image processing front. Now if you look into speech recognition, if you look into the text analytics part, everything is working on artificial intelligence. Okay, so this is how is the Tom and Jerry video what we have seen. Similarly, if you look at different another one which is nothing but one on another use case, I have some videos related to accidents, images related to accidents related to fog. If you look here, this happened during with in winter, and if you see, there are multiple images that I have provided which happened during fog. Similarly, I have some more images which happened during night. So these are the night accident pictures. So similarly, I have multiple different sort of pictures. What I'm going to do here in this particular case, in the sense, I'm going to train my model with those particular pictures. And once I train my model with those particular pictures, I'm training it for 10 iterations. I just trained it on a random with the 10 iterations. You see, for each and every iteration, you see it has really improved for each and every iteration, right? So if you see that once you have these iterations completed, it has learned with 78% accuracy. And what is it doing? Once you have the data available, tomorrow I'm giving a different image. You tell me to which type of accident is it with this particular image. So what is happening here? It should be able to tell me, see, I have predicted 0. Okay, that image belongs to 0 class. And what is the 0 class? 0 class is nothing but that is a car without any accident. If I provide any sort of accident picture, whatever I have provided is without accident. So tomorrow I provide with any sort of accident picture, you should be able to determine if it is one or in a fog, it happened in a lamp or night, or if it is on a without lamp, or it should be able to determine which class of accident it belongs to. So this is how normally you have lot of use cases, wherein we have lot of use cases in each and every day in our real life, so that you see that Amazon recommendations, Amazon video recommendation, Prime video recommendations, or the Netflix movie recommendations, all these are working based on the data science itself. Now, coming back to the other one, which I want to tell you on the roles, and we have seen what is data science till now. Many companies are hiring. We have seen some sort of real world implementations, how we can do. These are the ones that I have done as part of the POCs. But if you look into real world scenarios, there are multiple real world scenarios which we have implemented as part of the projects also. So if we have seen real world use cases. Now coming back to the roles in data science. So what sort of job opportunities normally we have in data science, in the sense, some people call machine learning engineer, some people call predictive analyst, some people call data scientist, data analyst. But end of the day, the job of a person will be not only from the analysis front, but also on the prediction front and also on the visualization front. So what is the job of this particular data scientist? In the sense, he is the one who should be able to tell the trends or the ups and downs, what is happening with the data. Apart from that, he should be able to tell what is the data talking about. Apart from that, it should be able to tell me what is the future that will happen based on the historical data. So all, if you look at different roles and responsibilities, end of the day, what a person doing will be the same thing from the modeling part or from the visualization part or from the analytic part. Everything will be done by any person has to do the same thing. So when I'm talking about the roles and responsibilities, let's talk something on the language front. So what are the main languages that we normally are using? In the sense, the main languages we normally use are most of the time in industry are R and statistics, R and Python. Okay, so R is a statistician's language. So when you're working on the only on the statistical modeling part, people prefer to use R. And if you go to ISRO, NASA, you see most of the time people using R for their statistical modeling. And nowadays, Python providing very good APIs or the libraries With support to deep learning and machine learning, people started using Python for analysis, modeling, and predictions and visualizations also. So when we are covering as part of the course, as part of the course, not only Python, R will also be covered as part of the course. So what is that we are going to cover as part of the course in the sense, we are going to look into the introduction to Python, because most of the people are, some people might be new to programming languages, and some people are really new to programming, or some people are new to Python. So we'll start from the introduction. And once we are done, we start with the machine learning, where we have multiple models. We have as part of the predefined models, which is part of scikit-learn package. So we have lot of predetermined modeling, so we go through each and everything. But one thing I should tell you, it's not only that you should learn the model, you should understand the statistics part of the modeling, so that tomorrow wherever you're going for your interviews, it is really helpful. Or if you're going with the customization part, it will be really helpful. So when at least from my friend, when I go through, I just don't teach what is decision tree or what is the random forest. I want the people to know what is the really stats behind that particular decision tree. I want them to dig deep into, I want them to know what is the statistics or the probability front, or calculus front on back of each and every model during the performance front. I want them to learn most of the time. So we normally dig into each and every part of each and every model, and we go through the entire course. So coming back to that, so we will be covering its probability part, statistical part, and the calculus part, because of these are the very much basics for each and everything. So it's, if you're really, if I, as a human, I understand that we normally don't remember whatever we have studied during our I mean in a schooling or intermediate or in degree. So we'll just revise the concepts. Whatever you have questions, always feel free. So we go through all these parts. And as I was telling you, text processing, natural language processing, and computer vision and image processing, whatever we have seen here is part of computer image processing and computer vision. And the neural networks, which is nothing but the deep learning part. We'll try to understand what are the models in the deep learning, and we will go through each and every part. And we will be covering some of the visualization stuff also as part of the course, which is not included here. But we will be covering up there are certain Seaborn libraries and Matplotlib libraries as part of it. So we will be covering all those as part of the visualization.